our next example, and notice all of my examples are going to look identical. I'm going to be given two linear equations, and I can use any method I want. If I wanted to graph these, I can find the point of intersection. If I wanted to use linear substitution, solve for the easiest variable, I'd find the point of intersection. Here's another method, algebraic. I'm not even going to touch graph paper, but I'm going to find the same point of intersection that I would with any other method, called linear combination or elimination. And we'll show why that ends up being the same name. Combination means combine, add two things together. When I add these together, notice what happens. 2x plus negative 4x is negative 2x. Negative 3y plus 3y, notice they cancel. 0 minus 1, negative 1. And look at what happens is, divide both sides by negative 2, and what I've got is x equals negative by negative 1/2. Hence why it's called elimination. When I combine them, I eliminate. Now, there was something very special that happened, and we'll talk about how to set that up here in a minute, but once I have one variable, plug it back in and get the other one. What's nice is, pick either equation, top or bottom. It won't matter. But that's what's kind of annoying about my combination method is there is no real easy way. You can either pick the smaller numbers or you can pick the numbers that could be mostly positive. It's all whichever one you want. In this case, let's take the top equation. I like zeros because that means a lot of things cancel out and it's easy to combine with things. I'm going to take that 1/2. I'm going to plug it in. 2 times 1/2 minus 3y equals 0. And now if I did want to go through all my operations, I could put that 2 over 1, multiply, top and top, bottom, bottom. But we know that half of 2 is 1 minus 3y equals 0. And what I could do is I could minus 1 divide by negative 3. But remember too that there's no rules on. I kind of like to keep my signs, clean them up a little bit. I'm going to add 3y to each side. That's going to give me 1 equals 3y, meaning everything's positive. Now divide by 3. My y is going to equal 1/3. And it won't matter what side that's on, but there's my ordered pair. My ordered pair is 1/2 comma 1/3. Think about where that ordered pair is. That's not a slope. That doesn't mean rise 1, run 2. What that means is on my ordered plane where here's 1, 2, 3, and I'm zooming in for a reason. 1/2, like on a ruler, halfway between. Where this would be 1, 2, 3, going up the y-axis. 1/3 means, like a hockey game, like the Blackhawks cut it into, 1/3, there's my ordered pair. Sitting right there in the middle of that box. If you were to look at this graph, there is no way you could look at two lines, and we don't care what the lines look like. I just made those lines up. But there's no way that if lines cross in the middle of a box, you go, oh yeah, that's definitely 1/2 comma 1/3. Algebraically, no sweat. All we got to do is divide. We may need to reduce, and we may have operations with fractions, but we get that exact value, no problems.